And we're trying to get it to become cotangent times cosecant. So remember thinking about like the way to approach these problems. Can you factor? Can you use conjugates? Can you get a common denominator? Those would be the three main algebraic methods that we use. The other option would be, could you just use an identity and start with an identity? So if you can't do an algebraic step, could you start with an identity? So those would be like the things to think about. So if you're making yourself a list, go down the checklist. I can't factor it, or factoring wouldn't work. Can't really use a conjugate. There's no common denominators defined because it's just one fraction. So if you say no to all the algebra, then maybe you can say yes to an identity. Cool. Could we say yes to an identity in number 7? Yeah, the numerator, cosecant squared minus 1, goes with the Pythagorean identity. 1 plus the tangent squared equals the cosecant squared. So cosecant squared minus 1 becomes cotangent squared. So again, just have like a little mental checklist as you're working through. So we can change the numerator to become the cotangent squared. Now again, we're trying to get cotangent times cosecant. Right now we have cotangent squared over cosine. So what would you try next? Peter? Yeah, so that's another identity. So in this one, we're not really doing a lot of algebra. We're using identities. So cotangent squared is a quotient identity, and it can become, he said, cosine squared over sine squared. And then the cosine is still on the bottom, which is really cosine over 1. So thinking that you have a fraction on the top and a fraction on the bottom. Now we're going to do a little bit of algebra. When you're dividing, you're really multiplying by the reciprocal. So if I'm dividing by cosine, I'm really multiplying by 1 over cosine. I'm just going to cross that off, change it to multiplication. Parker, what happens then algebraically? So if I have cosine squared over sine squared times 1 over cosine, what happens there?
Wouldn't it just be cosine over sine squared then?
Yeah, so the cosine cancels with one of them, and he said it just becomes cosine, no longer squared because the cosine canceled, but it is sine squared still. So now we have cosine over sine squared. Remember, the goal is to get cotangent times cosecant. Cole, where did you go from here?
I broke up the sine squared.
Yeah, so if something is squared, sometimes an identity is helpful, but if you use an identity here for the sine squared, that then has a minus sign in the denominator. And our goal is to keep this as multiplication. So another way of looking at sine squared is to say, really, it's sine times sine. So cosine over one of the sines becomes the cotangent. 1 over the sine is the cosecant, which is what we were trying to get. So sometimes separating an exponent and splitting it up helps get those two functions that we have in the expression cotangent times the cosecant. Questions on number 7? All right, so if we go down to the bottom and look at the last 2 problems, this says to rewrite the expression so that it is not in fractional form. Number 15, there are 2 different ways that I thought of to do number 15. One deals with using an identity immediately. The other one deals with doing an algebraic process. It's up to you what you notice. Jenny, what did you see with number 15?
I used the conjugate.
Yeah, so we can use a conjugate. So multiply it by 1 plus cosine. And then we have sine squared And then 1 minus cosine squared. And Jenny, 1 minus cosine squared. Almost forgot to write that conjugate part at the top. So sine squared times 1 plus cosine. And then she said the denominator is sine squared. So using the conjugate here, now I have sine squared over sine squared. It said to write it so it's not in fractional form. So now I have 1 plus cosine. The sine squareds cancel by using the conjugate, and you're just left with 1 plus cosine. So that's one way that you could have thought to do the problem. The other way to do the problem would be to immediately replace sine squared with an identity. What is the sine squared equal to? Peter? Right, so if I change that to 1 minus cosine squared, they cannot cancel yet. Remember, you're not allowed to cancel pieces. You're allowed to cancel a whole quantity. But if you factor the numerator, it becomes 1 minus cosine times 1 plus cosine. Because it's a difference of perfect squares. And the denominator was 1 minus cosine. Now I can cancel, and I still get 1 plus cosine. So I used an identity immediately instead of doing algebra. Replaced sine squared with 1 minus cosine squared, and then I factored it. And by factoring it, that denominator ended up canceling. So 2 ways to do the problem. There probably could be a couple different things to do, but depends on what you notice first. Questions on 15? So the last one, number 16, we have 3 over the secant minus the tangent. I'm just going to move this guy down. How would we start number 16? Directions just say to make sure it's not in fractional form. Kaden, what do you think? Multiply by the conjugate. That's probably one of the most used algebraic methods, the conjugate. So if you're not sure what to do, try the conjugate. So we have the secant plus the tangent and secant plus tangent. Kaden, what does the numerator become? And how about the denominator? Yeah. So the identity says 1 plus the tangent squared equals the secant squared. That means the denominator is equal to what? 1. Yeah, the denominator is equal to 1. So secant squared minus tangent squared, if I move tangent squared, by subtracting it to the other side, I have secant squared minus tangent squared. So the denominator is just equal to 1. So all of this becomes the number 1. That means we're just left with 3 times the secant plus 3 times the tangent. So conjugates, we use them a lot to help us simplify. Questions? Any other ones that I didn't go over that you would like to see? Nobody did Decades Day? No, I didn't either, obviously. My daughter has a Gwen, like Addie, the older daughter, loves 80s, 90s. She loves Gwen Stefani. She likes Madonna. I don't know who made her. Apparently I did, but I'm not sure why she likes Gwen Stefani and Madonna. But she wore both of those shirts. She's wearing the Gwen Stefani shirt today, and she wore the Madonna shirt on Sunday. I was like, man, I could have wore one of them. But they were in her hamper, so I wasn't going to wear anything that she wore and was dirty. So, oh well. But she's having Decades Day today. It's like, what are the chances? They had pajama day yesterday. How about that? Mr. Kane, I think, has a Leonard Skinner shirt on. You'll have to rate his ability to dress. What decade is he from? All right, so we are going to do a review today. If you are at home and you go to Google Classroom, there is a review worksheet for you. Everybody in here, you don't need to go to Google Classroom right now. But those of you at home, if you want to go to Google Classroom, there's a review worksheet, and it's actually it's a practice worksheet for section 5.2. You are free to leave the Zoom. If you find that you have questions as you're working, feel free to rejoin the Zoom. I will keep Zoom open for everybody at home. I'll post pictures of my worked out solutions too, but if you're at home, you are free to go. Test tomorrow, part 1. I'll answer any questions that you have at the beginning of class. Does anybody at home have questions? Feel free to email me as well, but otherwise, if you're at home, have a great day.